Welcome to Brain Vision.
We begin this question by choosing our frame of reference. So, I will choose that everything that is pointing upwards on the y direction is positive and everything that is pointing to the right on the x direction is positive too. Then, for the first item, we have to apply Newton's second law on the vertical axis. So, on that vertical axis, Newton's second law tells us that the net force is equal to the mass of the helicopter times the acceleration of the helicopter in that direction. But the helicopter is moving on the horizontal, meaning that it's not moving on the vertical direction. Therefore, the acceleration is equal to 0 in that direction. Then, the net force in the y direction is equal to 0. And the net force in the y direction is composed by the weight force, which is negative in our reference frame, and a portion of that lift force L. And the portion that composes the vertical part is this one, which I'll call Ly, so the y component of the lift force. And this is the x component of the same force. Then, Newton's second law tells us that the lift force in the y direction minus the weight force is equal to 0. Therefore, the lift force in the y direction is equal to the weight force, which is equal to 53,800 newtons. Now, what is the relation between the y component of the lift force and the magnitude of the full lift force? Note that we have a rectangle triangle using our components. This, the hypotenuse, is the full lift force, this is the x component, and this is the y component of that force. And this angle is 21 degrees. By calculating the cosine of this angle, we can get our relation. The cosine of 21 degrees is equal to the adjacent side of that angle, so L component y, divided by the hypotenuse L. Therefore, Ly is equal to L times the cosine of 21 degrees. Therefore, L times the cosine of 21 degrees is equal to 53,800. Therefore, the magnitude of the lift force is equal to 53,800 divided by the cosine of 21 degrees. And this gives us approximately 57,600 newtons. So this is the magnitude of the lift force. Now, to determine the magnitude of the resistance force, we have to apply Newton's second law on the horizontal axis. So on the horizontal axis, Newton's second law tells us that the net force in that direction is equal to the mass of the helicopter times the acceleration of the helicopter on the horizontal direction. Now, the helicopter is moving on the horizontal, but it's moving with a constant velocity. Therefore, the acceleration is equal to 0 in that direction too. Then, the net force in the x direction is equal to 0. But the net force is composed by two forces: the lift force x component and the resistant force R. Then, we have that the lift force x component, which is pointing to the positive direction of the horizontal axis, minus the resistant force is equal to 0. Then, L component x is equal to the resistant force. But what is L component x? Well, we can repeat this idea to get it. The sine of 21 degrees is equal to the opposite side of the triangle, Lx divided by the hypotenuse L. Therefore, Lx is equal to L times the sine of 21 degrees. Then, the resistant force is equal to L times the sine of 21 degrees. But we know that L is equal to 57,600. Then we have 57,600 times the sine of 21 degrees here. And this is approximately 20,600 newtons. And this is the answer of the second item.